All right, Algebra 2, Section 10.1, Permutations and Fundamental Counting Principle. Now, if you look at Example 2 in your textbook on page 683, I'll talk to you how I got these numbers and how we go about solving this particular type of problem. In our problem, we are told that there is a picture that's being framed. There are 12 different styles of the frame, 55 different colors, and a blue mat which has 11 different shades of blue. So to get the total number of ways you can frame the picture, you take the 12 ways you can pick a frame, the 55 different colors of the frame, and then the 11 different shades of blue, and you multiply them together. So the fundamental theorem, or the fundamental counting principle, simply states that if you are finding the total number of ways of doing things, then you take the total number of each different way, multiply them together. Example 3, we are creating a license plate for Texas, for the state of Texas. And in the state of Texas, the first character is a letter of our alphabet, followed by 2 numerical values, and then followed by 3 letters of our alphabet. Now, if we can have repetition of letters and digits, then in example 3, letter A, this is how we would go about doing it. The first character, a letter, is 26, because there's 26 letters in our alphabet. The second character would be a digit, a 1 digit, and there's 10 ways that we can choose that. We can go 0 through 9. There's 10 different ways. And then 10 different ways for the second digit. And then 26, 26, and 26 are the last 3 letters. So we'd get a total of 45,697,600. Now, if you do not have any repetitions of letters or digits, we would approach it this way. The first character, we have 26 different ways to choose that. We have 10 ways to pick the first number, only 9 ways to pick the second number, because if we choose whatever we choose for this one, it can't be repeated here. Now with the remaining 3 letters, since we chose 1 for the first one, we have 25 for this one, 24 for this one, 23 for this one. We multiply it and we get 32,292,000. All right, so far so good. All right, now let's suppose that we're at a book sale and you're going to buy 3 different types of books. You're going to buy a novel, you're going to buy a nonfiction, and then you're going to buy a comic book. Well, what if there's 5 novels to choose from, 3 nonfictions to choose from, and then 7 comic books to choose from? How many different ways can I make those 3 purchases? Well, 5 novels, 3 nonfiction, and 7 comic books multiplied together. There's 105 different ways that I can do that. So that is the fundamental counting principle, where you're taking the number of ways that you can do something, and then you can multiply those different ways together to find the total number of ways. Now, the next idea is that of something called a permutation. A permutation. Now, the way a permutation is defined, we define it as an ordering of objects when the order matters. For example, let's say I have 3 letters of the alphabet, A, B, and C, and I want to figure out how many different ways I can order two of these letters. I can have AB, I can have AC, I can have BC, I can have BA, I can have BC, and I can have, excuse me, CA. I already have BC. This should be CB. Okay, that's the different ways that I can order two letters from the letters A, B, and C. Okay, that's a total of 6 different ways. Now the formula for permutations is using something called factorial notation. Factorial notation, this is the notation for factorial notation. It looks like an exclamation point. Now what factorial means is this. If I have the number 3 factorial, that means that I start at 3 and I multiply by each integer below 3 till I get to 1, and I multiply that out and I get 6. Okay? Now there is one special definition, and that is 0 factorial is equal to 1. That's the special definition of factorial. Now the permutation, NPR, uses factorial. It's n factorial over n minus r factorial. So like in my particular case, in the example that I just showed you, I have 3 items, A, B, and C, and I'm choosing 2 of them. So that'd be 3 factorial over 3 minus over 1 factorial, which equals to 6, which is what I got when I did it out this way. Now, it is not necessary to know this formula. It's not necessary because permutation formula is built into your calculator, and I'll show you where it is. If you've got a calculator, to find the permutation, turn it on, okay? You go to the math button, probability, and you'll see NPR as the second menu item. You type in your 3, you type in your 2, press enter, you get 6. So you don't have to do it using the formula. Now let's suppose that we want to arrange 5 different items. How many different ways? Say I have 5 books. How many different ways can 5 items be arranged? Well, if I'm arranging all of the items in a group, then it's just simply 5 factorial. If I'm arranging 3 of the 5 books, then it would be 5 permutation 3, or 5p3. See the difference? Okay. Another idea behind this is a permutation of items when there are repetitions of one item in the list. For example, let's take the letters of the word ALA, BA, MA. Alabama. We've got the letters of the word Alabama. How many different ways can we arrange those letters? Well, first of all, we need to determine how many letters there are. There are 7. So it's 7 factorial. Now, because one letter, the letter A, is used 4 different times, that means that we have a repeated character. So when you do a permutations with a repetitive character, then you have to divide the factorial by, let's see, the letter A is in here how many times? 1, 2, 3, 4. 4 times. So this is going to be 7 factorial divided by 4 factorial. Now, just as on your calculator permutations were on there, factorial is on there as well. So turn on your calculator. If you'll go to Math, up at the top, highlight PROB, which is probability. Notice that factorial is the 4th value. So I'm doing 7 factorial, 7 math probability factorial divided by 4 factorial, and I get 210 different ways. Now, what if you've got more than one character that's being repeated? And we want to know how many different ways we can arrange these characters. Well, how many characters do I have to begin with? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 11 factorial over, I is in here how many times? 1, 2, 3, 4. S is in here how many times? 4. And P is in here how many times? 2. So we would do this way. So we would do 11 factorial divided by, now when you have multiple entries in your denominator, you want to separate this inside its own parentheses, over 4 factorial times 4 factorial times 2 factorial. $34,650. So that's how you do the fundamental theorem of, I think, fundamental counting principle and permutations. There's one other thing that they talked about in here, and that is the idea of tree diagram. Tree diagram is quite simple to do. So if you're interested in how to do this tree diagram, the first question on your worksheet involves the tree diagram. So I'm going to work that first question on your worksheet and show you how to do a tree diagram. So if you would, let's look at your worksheet. It is question number 1, and it says something to the effect that you have, for lunch, you can either choose milk, juice, or water for your drink, and you can have ham, turkey, or vegetable sandwich with your lunch. So a tree diagram would look like this. It would be milk, and with milk you could have ham, turkey, juice. You can have, vegetables. Well, that's dumb. Vegetables. Juice. You can have ham, turkey, or veggie. And then with water, you can have ham, turkey, or veggie. That would be the tree diagram. All right, so we have 3 choices for a drink, 3 choices for a sandwich, 9 different ways we could do this. The tree diagram supports this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that is your ideas involving chapter 10, section 1.